So we are looking at this module on binary trees, and we'll finish up today with this traversal algorithms that can be used to traverse the nodes of a binary tree. And so basically we want to have a listing of the vertices in the binary tree in a certain order. So we'll do it three ways. We'll call it as preorder, in-order, and post-order traversals. Okay. So the breadth first search algorithm we did is also a traversal algorithm wherein we start from the root node and visit the nodes based on the level numbers. So that is also a traversal process. Okay. All right. So now I have listed here the rules according to which we will traverse the nodes, and these rules will be very useful to remember. So we'll start with pre-order. So in the pre-order, again, we will be visiting the nodes and printing their node IDs, okay? And the time we print the node IDs is, or list the node IDs, is what we're going to consider. Okay, so in the pre-order, we'll start with the root node, print its ID right away. Okay, so we list the root node 0. And then, as the rule states here, we go to the root node first, and then print it, ID, and then go to its left subtree and print the IDs of all the nodes in the left subtree. And then go to the right subtree and print all the node IDs in the right subtree. So we printed the root node ID 0, so let us go to its left subtree. So this is the left subtree 136, and I've listed it here. So 136 is the left subtree. So now we'll apply that rule recursively. That means we'll print now the root ID of the left subtree. The root ID of left subtree is 1. So we'll go ahead and print the 1. So the numbers I have listed on the top is the order in which we are going to print them. So we first printed 0, and then we printed 1. And then the rule says go to the left subtree again. So go to the left subtree of this root node, which is comprising 3 and 6. And in this subtree, again, we print the root ID, which is this 3. So vertex 3 or node 3 is the third vertex to be printed. Now go to its left subtree. Now there's no left subtree for node 3, so there's nothing to print. So we printed the root of this subtree. Now go to the left subtree, there's nothing out there. So now go to the right subtree and print the root of that right subtree. And this subtree just comprises of one node, and that itself is the root. So we print the root 6. So that's the fourth vertex of that fourth vertex we printed. Now there's nothing to go to the left subtree of this root node, but there's nothing to go and print. So go to the right subtree of node 6, that's nothing to go and print. So essentially we are now done with this left subtree. So we printed the root, went to its left subtree, applied the rule recursively, and printed the nodes in the left subtree. So now we'll go to the right subtree and do the same thing. So in this right subtree, the root of that right subtree is node 2. So we'll go ahead and print that node 2. That's the fifth vertex we printed. Now we'll go to the left subtree and print all the nodes in the left subtree of node 2. Now in the left subtree of node 2, node 4 is the root. So we'll go ahead and print the root, which is the sixth vertex to be printed. Then we'll go to the left subtree of node 4 and print all nodes there, starting from the root node, which is 7. And that's the seventh vertex to be printed. Now go to the left subtree of node 7, print all the nodes there, starting from the root of that subtree, which is 9. So that's the 8th vertex we printed. Now we'll go to the left subtree of node 9, but there's nothing to go and print. So try to go to the right subtree of node 9, again nothing to go and print. So essentially we are now done with the left subtree here. Now we'll go to the right subtree comprising just node 5, and we'll print that. So that's the last vertex to be printed. Sorry. So we printed this, right? So we printed the left subtree. So after printing 9, we need to go to the right subtree of node 4. So root here, left subtree, and right subtree, that's node 8. So print node 8, that's the 9th vertex to be printed. So now we are done with the entire left subtree here. We'll go to the right subtree, which is this node 5. So that's the last vertex to be printed. So this is a traversal order. So let me go through it one more time. We start with the root node, print the root node right away. So that's what the rule states, root left, right. So print the root node and go to the left subtree of the root node that comprises 1, 3, 6. So in this left subtree, the root node of the left subtree is node 1. So we'll print that node 1 right away and then go to its left subtree. The left subtree here again, we'll start with the root node, which is 3, so print it, and then go to its left subtree. Now there's no left subtree for node 3, so we'll go to the right subtree for node 3 and print the 6. So we're done with that subtree. Actually, this is the root of that subtree, so we printed it and we should have gone to the left subtree, but there's nothing to the left as well as nothing to the right. So that's why I say just start with 6. So we are done with the left subtree of node 0. So we have to go to the right subtree of node 0. So the right subtree of node 0, we start with the root node 2 and print it right away. Then go to the left subtree, which is comprising 4, 7, 8, 9, where 4 is the root of that subtree. So we print that 4 and go to the left subtree of node 4, which is 7 and 8. So we now are in the left subtree 7 and 8. So 7 is the root, so we print the root 7. Go to the left subtree, which is this one, and that's 9 is the root of that subtree. We print the 9. There's nothing to the left, so we don't have anything to print, nothing to the right. So we're done with this subtree, and with that we are also done with this left subtree, 7 and 9. So now we have to go to the, now if there was a right child of this 7, we should have gone after this 9, we should have printed the right child of 7. There's nothing to the right of 7. So we printed the root 7, went to its left subtree, there's nothing to the right of 7, so nothing to print. So now we can say we are done with this left subtree, go to the right subtree of 4, and 8 is the vertex that you can print here. Again, that's the root of that subtree. We print it, and then if there's anything to the left of 8, we should have printed it now, but it's nothing to the left of 8, nothing to the right of 8. So we are essentially done with the entire subtree starting from 4. Now we have to go to the right subtree of 2, and we see this subtree where we have 5, so we can print this 5. Again, that's the root of that subtree. Now, if there's anything to the left of 5, we should be printing that now. There's nothing there, and there's nothing to the right of 5 also. So we're done with this right subtree. We already started the root, left subtree, right subtree. So now we are done with this entire right subtree of node 0. Okay. So we kind of go all the way down and then back up, go to the right, start on the root, go to the left subtree and then right subtree, and do this in a recursive fashion. Okay, so any question? We'll do the 3 traversals and then maybe take one more example and do that. But it just comes by practice. You have to try a few binary trees and then you can get it. All right, so let us do the next traversal. So this is in-order traversal. So again, the rule for in-order traversal is this. Print all the nodes in the left subtree, then print the root node, and then print all the nodes in the right subtree. So you see the difference. In the pre-order, you print the root first, and then print everything in the left subtree, and then print everything in the right subtree. and this rule is applied recursively. Whereas in order, we print the nodes in the left subtree first, and then print the root, and then print its right subtree. So that means, like in this binary tree, we don't print the root 0 right away in order traversal. We visit all the nodes in the left subtree and print them. And while printing the nodes in the left subtree, we'll again apply this rule recursively. Okay, so we'll again start with this node 1, but don't print it right away. Go to its left subtree and print everything in the left subtree of node 1. So that's what we're going to do now. So start with the root, but don't print the root right away. We have to first print everything left subtree of the root node 0, starting with 136. Again, don't print the root node 136 right away. We have to go to the left subtree of node 1, which is this 3 and 6. Again, don't print everything right away. Go to the left subtree of node 3, which is the root of that subtree. Now you see there's nothing to the left of 3. Okay, so if there was a node anything to the left of 3, we should be printing that first because that's the left subtree. So since there's no left subtree for node 3 in this tree subtree here, there's no left subtree for node 3, we'll now go to the root, which is 3, and print 3. So 3 is the first node to be printed, the ID. So now go to the right subtree of node 3, which is this subtree. Now, if there was a left subtree for node 6, or just a node, we should be printing that node ID. But since there's no left subtree for node 6, we go to the root of the subtree, which is 6 itself. So we'll be printing now this root 6 as a second vertex. If there is a right subtree for node 6 and there's a node there, that's the next node to be printed. But there's nothing to the right of node 6. So essentially we are done with this left subtree. So now we can go to the root, which is 1, and print node 1. Now, if there was a right subtree for node 1, that is a subtree you should be visiting now and printing the vertices there. But there's no subtree for right subtree for node 1. So we're basically done with printing the left subtree of node 1, printed the root of the subtree, and basically since there's no right subtree for node 1, we can say we are done with printing all the nodes in the left subtree of node 0. And now we are ready to print node 0. That's the fourth vertex to be printed. So we started with the root, but don't print the root right away. Go to its left subtree and print all the nodes there first. And we have done that, and now come back to the root and print the root node ID. So now go to the right subtree. So the node 2 is the root of the right subtree, but we don't print it right away. First print everything in the left subtree of node 2. So these are the nodes, the left subtree of node 2. And so 4 is the root of that subtree. Now again, don't print 4 right away. Go to the left subtree of node 4, which is 7 and 9. And 7 is the root of that subtree. So don't print 7 right away. Go to the left subtree of node 7, which is 9. Now that's the root of that subtree. Now there's nothing to the left of 9. If there was any vertex to the left of 9, that will be the vertex that will be printed now. Now there's nothing to the left of 9. So now we can visit the root 9 and print 9. So that's the fifth vertex to be printed. Now there is nothing to the right of 9. So there's nothing to print. And that means we are now done with the left subtree of node 7. And now we'll go to node 7 and print node 7. That's the root of that subtree. Now, if there was a right child of node 7, that's the subtree now we'll be printing. There's nothing to the right of 7. So we're basically done with this subtree comprising 7 and 9. Now we visit the root node, which is 4, which is now the root node of this subtree, for the 7 and 9 was the left subtree. So we print the root node ID 4, that's the seventh vertex to be printed. So now we can go to the right subtree of node 4, which is 8. Now 8 is the root, so we have to first see if the 8 has a left child, and 8 doesn't have a left child, so we'll now just print 8, which is the root of the subtree. That's the 8th vertex to be printed. Now there's nothing to the right of 8. If there's anything to the right of 8, we should be printing that now. So you're done basically with this right subtree of node 4. So node 4 is the root, 7 and 8 or the left subtree, 8 was the right subtree. And that itself is the left subtree for node 2. So node 2 is the next vertex. That's the root of this subtree, where 4, 7, 8, 9 was the left subtree. So 2 is the next vertex to be printed. And now we go to the right subtree of node 2, where we have 5 as the root of that right subtree. Now, if there was anything to the left of 5, we should be printing that now. There's nothing to the left of 5, so we print the root ID, which is 5, and then check if there's anything to the right of 5, there's something to the right of 5. So we're done with printing the right subtree for node 2. So started with the root node ID 2, but don't print it right away, printed the left subtree, then printed the root, and then printed the right subtree. So this we're done with the right subtree of node 0. Okay, so let me repeat the process. So in preorder, again, when we visit the vertex for the first time, which will be the root, we'll be printing it right away, and then go to the left subtree and print all nodes there starting from the root. Then go to its left subtree and print everything there starting from the root. In the case of in-order traversal, we start with the root but don't print it right away. We'll go to the left subtree and print everything there and then come back and print the root. So, and again, we apply this rule recursively. So in the left subtree, we identify the root but don't print it right away. Go to the left subtree of the root of that subtree. So this is the left subtree 3 and 6. Again, don't print the root of the subtree right away. Check if that root has a left subtree and there's nothing to the left of 3. So now we can come back to the root, which is 3, and print it. Then go to the right subtree. So you can see the root is printed the second time you visit the vertex in in-order traversal. Whereas in pre-order, the root is printed the first time you see it. So we print 3, then go to the right subtree of node 3, which is just 6. Now 6 is the root of that subtree. If there was anything to the left of 6, that should be the next vertex after 3 to be printed. But there's nothing to the left of 6, so we print 6 now. That's the second vertex to be printed. Now if there's anything to the right of 6, we'll be printing that now. There's nothing to the right of 6. So with this process, we are done with printing everything in this subtree comprising 3 and 6, which is the left subtree for node 1. So now I'll go one level high, and this is now node 1, that's the root of this subtree, where 3 and 6 were the left subtree. So we'll print node 1, that's the third vertex we printed. So that is the root. So we check if node 1 has any right subtree. There's nothing to the right of node 1. So that means you're done with printing everything comprising 1, 3, 6. And these were the left subtree for node 0. So now node 0 is visited the second time, so we'll print that root. So now we're done printing the root. So go to the right subtree of node 0, which is all these vertices, starting from 2, which is the root of that right subtree. But don't print that root right away. Go to its left subtree and print everything there, starting from 4. Again, that's 4 is the root of that subtree. Don't print it right away. Go to its left subtree, starting with 7. And 7 is the root, so go to its left subtree, starting with 9. That's the root of that subtree. If there's anything further to the left of 9, that will be the next vertex we printed after this 0. But there's nothing to the left of 9, so now print node 9. Okay, and now there's something to the right of 9, so that means we are done with printing this subtree comprising of 9. So go one level above, and that is now the root of that subtree. So we printed the left subtree, now the root is 7, we print 7, and we'll check if the 7 has any right child. And if there's only right child, that will be the right subtree we'll be printing. There's nothing to the right of 7, so we can say we're done with printing the nodes 7 and 9 that will form the left subtree for the node 1 level above, which is 4. So that's the root node. So print the root node 4 of that subtree and go to its right subtree, which is 8. Now 8 is said to be the root of that subtree, and it doesn't have any left child. So we can now go to the root of the subtree 8 and print it, and then check if it has a right subtree. There's nothing to the right of 8 also. So we're done with printing the right subtree 8 of 4, and so that means you're done with this subtree comprising 4, 7, 8, 9. You're back to the root of this left subtree, which is node 2. That's the root of this subtree. So we print node 2 and then go to the right subtree, which is node 5, and there's nothing left of node 5. If there was, we should be printing that first. There's nothing there, so we'll print node 5, and then there's nothing to the right of node 5. So when I'm printing the right subtree, now we are done because printed the left subtree, then the root and the right subtree. Now you see here, we apply this rule recursively. So in this listing that we got by traversing the vertices, we can cross-check whether we printed everything right. So 0 is the root, right, of the overall binary tree. So everything to the left of 0, which will be 1, 3, 6, right, should be printed to the left of node 0. And everything to the right of node 0 should be printed to the right of node 0. And this rule can be verified recursively. So 1, 3, 6, where now the left subtree, where 1 is the root. So 1 is the root. So 3 and 6 form the left subtree of node 1, and they should be printed to the left of node 1. So that is true. Now again, 3 is the root, and 6 is the right child of node 3. So 6 should be to the right of the root. So you have the root, and everything to the left of the root will form the left subtree, and everything to the right of the root should be from the right subtree. And you can again cross-check recursively at every level. So in this level, 2 is the root. We have it here. 5 is the right child of 2, and that's the right subtree. And 5 is the right of 2. And everything to the left of 2, which is 4, 7, 9, 8, you see appear here to the left of 2. And remember, they should be to the right of 0, which is the root, and but to the left of 2, because now we have to look at this subtree. For 2, 4, 7, 8, 9 form the left subtree. So they are to the right of 0, but to the left of 2. Now 9, 7, 4, 8, 4 is the root. So 4 is here, and 8 is the right child of 4. So 8 should appear to the right of 4, where 7 and 9 should appear to the left of 4. And between 7 and 9, 7 is the root, so 7 appears here. 9 is the left child, so 9 should appear to the left of 7. So you can cross-check like this whether you wrote the node traversal correctly. And you can also check for pre-order traversal. Let us see what we have. And again, in pre-order traversal, the rule is you print the root first right away. So that means for the overall binary tree, 0 is the root, so that should be printed first. And now for 1, 3, 6, 1 is the root. So among 1, 3, 6, 1 should have been printed first. So that's what we can check in pre-order traversal. Then between 3 and 6, 3 is the root, so 3 should be printed first before 6. Then of course 6 itself is the root, so that's printed by itself. Now 2, 4, 5, 7, 8, 9, 2 is the root, so among these 5 vertices, or 6 vertices, 2 is printed first. Then among 4, 7, 8, 9, 4 is the root, so among 4, 7, 8, 9, again, they should appear together in some combination. And in that combination, 4 is the first vertex there, and that's the root of that subtree, 4, 7, 8, 9. Excuse me. And now 7, 9, 7 is the root, so they appear as 7 and 9 with 7 printed first. So that's what we can check in pre-order, whether the root of that subtree is printed first. Okay. Whereas in order, we can check whether the left subtree is printed first, followed by the root, followed by the right subtree. Okay, I think this is. So before we do that, let me show you the code that we can do for pre-order traversal and same logic can be applied for in-order and post-order traversal too. So when we want to print vertices using this traversal algorithms, was there any question? Okay. So when we print vertices using traversal algorithms, we'll use two functions. Again, these are part of the binary tree class. So these are member functions of the binary tree class. So the first function will be kind of calling from the main function to start this process. Is we can call it as preorder traversal. So this is like a trigger, the starting function to trigger this start this traversal process. So this function calls another member function. Let us call it as preorder traversal. So this is the actual function which will be traversing and printing the vertices. And this is going to be a recursive function. As you saw, the whole process is recursive in nature. And according to our convention, we'll have the root node ID as 0. So I have just listed here 0, which is also the root node ID. So I have now called this preorder traversal function, and node ID is 0. So it checks 0 is -1, it's not true, so we don't come inside, and we'll just print the root node ID. Cout node ID will print that 0 first. And then call preorder traversal of what? On the left child of node 0, right? So that's what we're doing here. So array of BT nodes of node ID. Again, remember this is a member function of the binary tree class, so it should be able to access the array of BT nodes and that node object corresponding to the root node ID 0. So on that, for that object, we'll try to get its left child ID. Okay, so that's the ID of the left child you're trying to get, and if that means if the left child exists, it will be some ID not -1. If the left child doesn't exist, then it will be the ID of the missing left child will be -1. So we are calling preorder traversal on the left child node ID. So now this preorder traversal, another instance of preorder traversal will be called. So this again, remember recursive like a factorial program. We have called the preorder traversal of preorder traversal on node 0, and we printed node 0, and now we have called preorder traversal on node 1. Okay, depends on this tree. So let me copy this here. So this is the tree for us. So the left child ID for node 0 is 1. So again, this is not pre-order figure, right? So this is post in order figure. So let me go to the pre-order figure and copy this. So we printed node 0 and called pre-order traversal on the left child ID, which is 1. And 1 is not -1, so will not be going to this if block, will come and print cout 1. So 1 is printed. And then call pre-order on the left child ID of 1, which is 3. So we go here. Oops. So we'll call pre-order traversal on the left child ID, which is 3. Then again, 3 is not -1, so we don't go inside and just print cout node ID 3. So that's the third vertex to be printed. And then call preorder traversal on the left child ID of node 3. So the left child ID of node 3 doesn't exist. So that means we would be calling preorder traversal and pass -1 as the argument. Since now we'll call this now preorder traversal with node ID being -1, -1 is equal to -1, so we simply return. And what that return means is we are returning from this function preorder traversal of -1. So that means this, what is called this stack frame, will be cleared. This portion of the stack frame is cleared. So now the top of the stack is this instance preorder of 3. And preorder of 3 we had called preorder of -1 and we just returned from this line, right? So in preorder of 3, we called preorder of -1. Preorder traversal was -1. So the control returned back from this statement. So now we are ready to call preorder traversal on the right child of node 3. So now we'll call preorder traversal on the right child ID of node 3, which is 6. So preorder traversal on node ID 6, which is not -1, so we don't go in here, but we'll print node 6. That's the next vertex we printed, and then call preorder traversal on the left child ID of node 6. So left child ID of node 6 is -1. So we would have called that preorder traversal on the left child, which is -1, and this means node ID is -1 currently in this preorder instance. -1 is equal to -1, so we return from that function. So we got this statement executed, preorder of -1 inside this preorder function for for node ID 6. So now go to this statement. We'll call preorder on the right child ID of 6, which is also -1 because node 6 is a leaf node, doesn't have a left child or right child. So we are done with, we are going to call preorder of -1 using the right child ID. And again, now in this function, node ID is -1 and -1 equals -1, so we return from this function. So we got both the statements executed for preorder of 6. We printed node 6, printed everything in the left subtree of node 6. Of course, it was -1, so we got that processed, and now we have processed the right subtree of node 6. So basically, this we are done with this function with regard to node 6. So we can return again because there's nothing more to execute in this function. So the top of the stack is now node 6. So remember, from node 6, we call the left child ID, got everything executed from node 6 and printed everything. So now we can execute this statement in this preorder function for node 3. So we'll call preorder on the right child of node 3. That's what we just executed. And we are done with this function. So we can now go to the top of the stack, which is preorder of 1. So in preorder of 1, we had, where was the code? The preorder of 1, we had called on the left child ID node 3 and went through the whole process so far. So now we are ready to call preorder on the right child of node 1, whereas the right child ID is -1, doesn't exist. So we will be calling that function and simply returning from that function. And we're done with this function, and also we'll be done with preorder of 1 because there's no more statement execute in preorder of 1. So we're done with preorder of 1. The top of stack is just preorder of 0, and there we are just executing this statement, preorder on the left child of node 0, which were 1, 3, 6, and we went through all the process. Now we are ready to call preorder on the right child of node 0. So that means we have to call preorder on node 2. And node 2 is not 0, so we'll be printing node 2, and then we'll be calling preorder on the left child of node 2, which will be node 4, and we'll be going through the whole process of printing everything in the left subtree of node 4. So you see how the recursion is working, okay? So you need to have a good understanding of this process. And again, in preorder, you print the node ID first and then call a preorder traversal on the left child. And that will take off the recursion process of printing everything in the left subtree. And once you come back from the left subtree, you call the preorder traversal on the right subtree by calling the right child ID. That will take off printing everything because you live in the right subtree. And with that, we're done with that function, for which you call the preorder traversal on this node ID. So that's we're done with printing everything in that subtree comprising the root and everything to the left of that root and to the right of that root. So this itself would have been the left subtree of the parent node, and will then go to the right subtree. Okay. Now, this logic can be extended for printing vertices in order traversal also. So I'm giving the idea right away. The only thing is you have to do is switch the statements. So if you're doing in order traversal, have a member function say print in order traversal and call in order traversal and pass 0, the root node. And in order traversal, you don't print the root node right away, you print everything in the left subtree. So that means have a function in order traversal and node ID and have the statement as it is, node ID -1 means return. But don't print the root node ID, the root node ID right away. First do in order traversal on the left child ID. So once you are done with the in order traversal on the left child ID, now have the cout statement where you print the node ID. And after printing the node ID, have in order traversal on the right child ID. And that will take care of recursively printing everything starting with the in order traversal on the left subtree, then the root of that subtree, then the right subtree. Easy now. Okay, so in post-order traversal, the rule is this. Start with the root node, but don't print the root node right away. Print everything in the left subtree, then print everything in the right subtree, then print the root node. So that's what we're going to do. So start with the root node, don't print it, go to the left subtree, print everything there. Then go to the right subtree, print everything there, then print the root node. So by now itself, you should have got the idea that in the post-order traversal, the root node will be the last node printed. So for the entire binary tree, 0 is the root node. So that should be the last node that gets printed. So everything in the left subtree, which is like 1, 3, 6, will be printed first. Everything in the right subtree, which are this 2, 4, 5, 7, 8, 9, will be printed now, and then the root. Now again, we recursively follow this process in each of those subtrees. So let us go through this and then we'll come back and check that listing. So we have to print now everything in 1, 3, 9. Now 1 is the root, so don't print the root right away. Go to the left subtree and print everything there. So in the left subtree, 3 is the root, so don't print it right away. Go and check if there's a left subtree for node 3. There's nothing to the left of node 3. So now we have to check if there's anything to the right of node 3. There is 6. Now 6 is the right subtree of node 3. So check if 6 has a left child. If 6 has a left child, that will be the one that should be printed first. There's nothing to the left of 6. Now check if 6 has a right child. If the 6 has a right child, that should be the one that should be printed now. There's nothing to the right of 6 either. So now we can print the root node 6. Okay. There's no left child, no right child, print node 6. That's the first vertex to be printed. So now we have printed the right subtree of node 3. We tried to print the left subtree of node 3. There was nothing there. Print the right subtree of node 3. And now we can print the root, which is 3. And that's the second vertex to be printed. So basically with this, we have printed everything in the left subtree of node 1. And we'll check if there's anything to the right of node 1. There's nothing to the right of node 1. If there was anything to the right of node 1, we'll be printing that now. There's nothing to the right of node 1. So now we'll be printing the root node 1. Okay, that's the third vertex we printed. And with that process, we are done with printing everything in the left subtree of node 0. So we'll go now to the right subtree of node 0. So we'll print everything in the right subtree and then only we'll be printing the root. Okay. So in this right subtree, 2 is the root. We'll don't print it right away. We'll print it. We'll print the left subtree of node 2, which is 4, 7, 8, 9. Now 4 is the root of that subtree. The left subtree is 7 and 9. Now again, 7 is the root, so we'll go to the left subtree of 7, which is 9. Now if there's anything to the left of 7, we'll be printing, sorry, left of 9, we'll be printing that first. There's nothing to the left of 9. There's nothing to the right of 9. So now we'll be printing 9. So 9 is the fourth vertex we printed. Now we'll go to the root, which is 7. There's nothing to write off 7. If there was anything to write off 7, we'll be printing that now. There's nothing. So we'll now print the root, which is 7. That's the 5th vertex we printed. Now we are done with 7 and 9. That is the left subtree for node 4. We'll go to the right subtree, which is 8. Now, if there was anything to the left of 8, that would be the 6th vertex to be printed, but there's nothing to the left of 8, there's nothing to the right of 8, so we're printing 8. And after that, we're done with the left subtree, we are done with the right subtree, so now we are ready to print the root of the subtree, which is 4. That's the 7th vertex we printed. And with that, we are done with printing everything in the left subtree. So now we'll go to the right subtree, which is having this 5. Now, if there was anything to the left of 5, that should be printed now. And if there's anything to the right of 5, that should be printed. Neither left child nor right child are there. So we'll go now to root node, which is 5, print now 5. So done with the left subtree, done with the right subtree. Now we have to print the root, which is 2. So that's the 9th vertex we printed. So with that, you are done with the left subtree as well as the right subtree. Now we can print the root, which is 10. Okay, so once we get the post-order traversal, we can again check if at any level for any subtree, the root should appear at the end of that listing of the vertices. So for entire subtree, 0 is the root, so 0 appears as the last vertex we printed. Now among 1, 3, 6, 1 is the root. So again, 1, 3, 6 form the left subtree, so they should be appearing together as some combination. It cannot be like 6 and 3 or here 1 is somewhere to the right. No, they should appear together as one combination because these are 3 nodes that form the left subtree of node 0. So we'll be printing the left subtree of node 0. That means we will be printing 1, 3, 6 in some combination, and that's what it is. So they should appear together with no other vertex coming between them. So 1, 3, 6 is printed as 6, 3, 1 because now we see according to post-order traversal, the root should appear at the end. So 1 appears at the end. And again, 3, 6 should be printed together where 3 is the root. So 3 appears at the end of that listing and 6 by itself now is the root, so it's printed there. Now, for this subtree 2, 7, 4, 5, 8, 9, 2 is the root, so 2 appears at the end. Now among 4, 7, 8, 9, they appear to get as 9, 7, 8, 4, so 4 is the root, and 7, 9, 7 is the root, so they appear as 9, 7, and then of course the leaf nodes. We cannot check the leaf nodes. No, basically in this post-order traversal or pre-order traversal, all we can check is whether the root of that subtree appears either as the last node in the case of post-order or either as the first node in the case of pre-order. Okay. Only the in-order traversal you can check the subtrees in the sense that for node 0, the root, everything in the left subtree appears to the left of node 0. Everything in the right subtree appears to the right of node 0 and recursively satisfied. For this subtree 2, 7, 4, 8, 5, 8, 9, 2 is the root. So everything to the left of 2, 9, 7, 4, 8 should be the left subtree of node 2. And everything to the right of 2 should be the right subtree of node 2. Okay, so that's what we can check with in-order traversal. Any questions so far? Okay, so we'll kind of finish it up by making use of what we just observed. So what we are now going to do is what we did just now since in the beginning of the class is given a binary tree, we saw how to write the pre-order, in-order, and post-order traversal. So now what we'll do is given 2 of the 3 traversal listings of the vertices, like in this case, you're given the in-order and post-order traversal, but not the binary tree. You're just given for some binary tree, you are given the in-order traversal order of the listing of the vertices and the post-order listing of the vertices. Using these 2 information, we should now be able to construct the binary tree for which this in-order and post-order traversal correspond to. So this is another way of looking at the problem, and we'll just make use of the property we just saw. Um, Now, in order for such problems, I should give you between the two orders, I should always give you the in-order traversal. I can either give you the post-order traversal or the pre-order traversal. So combined with the in-order and post-order or pre-order, you should be able to construct a binary tree. So let us see how to do that. So let us assume we are given the in-order along with the post-order. Now again, the rule is, as I said, the post-order or pre-order can be used to identify what's the root of some subtree. And the in-order traversal can be used to identify the left subtree and the right subtree of that particular root. So we'll start with identifying the overall root. So we need to look at the post-order first. So the post-order, the root appears at the end. So 0 is the root. So once you identified the root, come to the in-order traversal and decide what are the nodes that form the left subtree and right subtree of the root. So 0 is located somewhere in the middle, and 361 should be the left subtree of the root 0, and 974825 should be the right subtree of node 0. That's what we can decide right now. So we have basically identified the first level of that binary tree. So now we need to identify or explore further among 361 what is the root, and then decide the left and right subtree of that root. So that's what we'll be doing now. So among 361, to identify the root, look at the post-order traversal. They should appear together, as I said, in some combination, and the last vertex in that combination will be the root of that subtree. So 1 is the last vertex in that combination. So 1 is the root of that subtree. So now we are looking at this level. So among 361, 1 is the root. So now we need to figure out what about 3 and 6. So go to in-order traversal. In-order traversal, you see 1 is the root, and both 3 and 6 are to the left of the root. So that means both 3 and 6 form the left subtree of the root. So that's what we can identify for now. 1 is the root of the subtree, and 3 and 6 are the left or part of the left subtree of node 1. So now we'll do the same thing for 974825. We need to first identify the root. So 974825 appear like this. And 2 is the last vertex. So 2 is the root of that subtree. And we need to identify now the left subtree of 2 and right subtree of 2. So go to the in-order traversal. 974825 appear like this, where 2 is the root, 5 is the right subtree, and 9748 is the left subtree. So that's what we can decide for now. So now again go to the next level. So 3, 6, we identify the root. They appear as 6, 3. So 3 is the root. And go to in order, they appear as 3, 6. So 6 is to the right of the root 3. So 6 should be the right child of node 3. Now we have 9748. So go to the post-order traversal. First identify the root of that subtree. 4 appears at the end. So 4 is the root of that subtree. So now go to in-order traversal. So they appear as 9748. So to the left of 4 you have 97. So that will be the left subtree. And to the right of 4 you have 8. That will be the right subtree. So now we have to just figure out 97. So go to the post order, they appear as 97. So that means 7 is the root. And we have to figure out whether 9 is the left or right child of 7. So for that, go to the in-order traversal. They appear as 9, 7. So that means 9 is to the left of 7. So 9 is the left child of node 7. So with that process, we should have constructed the entire binary tree now. So as a question, what I could ask you is, given the in-order and post-order traversal, first you should construct the binary tree like we just did, and now you should be able to do the third traversal, the pre-order. So we can come up with the pre-order traversal of the binary tree that we just built. Okay, so that could be a complete question. So we'll do one more example. So now given the in-order and pre-order, we should be able to build a binary tree and then do its post-order traversal. So again, we should start the process by identifying the overall root of the binary tree. So for that, we need to always, when you want to look at the root or identify the root node, look at the pre-order traversal or post-order traversal, whichever is given. So in this case, we get pre-order traversal. So in pre-order, the root should appear first among the vertices in that subtree starting from the root. So here root appears first, which is 0. So root 0 is the root node ID. Then you have all the nodes out there. So now we need to figure out among these nodes, what are the nodes that are the left subtree of node 0 and right subtree of node 0. So for that, we look at the in-order traversal. So 0, the root is here. So everything to the left of the root, 361, will form the left subtree. Everything to the right of the root, 97485, form the right subtree. And then go about now the process of these two subtrees. Among 361, they appear as 136. So 1 is the root. And now we have to look at the in order. Again, 3 and 6 appear to the left of 1. So 3 and 6 will form the left subtree of node 1. Now among 97485, we have them listed as 247985. Yep, this is a combination in which this 6 vertices are appearing. So 2 is the root of this subtree. Now go to the in-order traversal. So we have 2 here, and 9748 form the left subtree, 5 forms the right subtree. Now, for 3, 6, so done with this level. So now we can figure the next level for 3, 6, 3 and 6. That's the order. So it means pre-order. So 3 is the root. Now go to the in-order. 6 appears to the right of 3. So 6 should be the right child of node 3. Now for 9748, they appear as 4798. So 4 is the root. Now look at the in-order. They appear as 9748. So 4 is the root. 8 is the right child ID. And 97 appear as the left child node, so left subtree. Then go to the pre-order. They appear as 79. So 7 is the root. And then go to the in-order, 9 appears left of 7, so 9 should be the left child ID of 7. So that's the entire binary tree. So we can then, again, of course, you can cross-check. Once we build a binary tree, we can try to run the algorithm and write the in-order traversal or the pre-order traversal. We should get this same listing. That's another way we can also cross-check whether we built the correct binary tree. Okay. Any question?